Welcome everyone! Today we learn how to execute basic queries with Elasticsearch in .NET. So as a prerequisite, we need to install Elasticsearch and Kibana with Docker and Windows. You can check out my video, I'll provide the link in the description below. The first step is to establish the connection with Elasticsearch in .NET. So go to Visual Studio and create a new ASP.NET Core NT application. Define the name, select the .NET version and create the project. Install the required NuGet package to establish the connection with Elasticsearch. So I'll open the package manager console, type install package elastic.clients.elasticsearch, execute the command. Now go to the program.cs file and add the Elastic client. Create a new settings property to define the Elastic connection settings. So add a new settings property, create a new Elasticsearch client settings. We'll pass the local instance URL from Elasticsearch, which in this case is HTTPS localhost, and the default port. Add authentication. So define a new basic authentication with username and password. The username by default is Elastic and the password. We'll open the output terminal and copy the password. And finally, we'll trust the local certificate. So we'll call the service certificate validation callback function and allow all. Please don't do this in production, it's just for the purposes. And to apply dependency injection, we'll add the Elastic client as a singleton. So call build.services.add singleton and create a new Elasticsearch client by passing the settings. Close this package manager console. Let's start with the match all query. So define a new get endpoint and we'll define a match all root. Inject the Elasticsearch client and define the body of this endpoint. Perform a new search request. So create a new response variable and asynchronously I will call the search async method. I will need to define the document return. In this case, we'll return a product. Define this document as a record with 4 properties. So create a new record called product with 4 properties, the name, the color, a decimal price, and finally a created date. Define the search parameters. The first one is the index. We'll return the documents from a product index. Add a second parameter to define the size of the response. By default, Elasticsearch returns 10 documents. So we'll return all the documents. We have 20 documents in the index. And finally, add the match all query. So call the query method and create a new lambda expression called the match all function. And we just simply create a new match all query. Finally, we'll return the documents from the response. We'll use OpenAPI and Scalar to display an interactive API. So open the package manager console to install OpenAPI. Clear the console and type install package Microsoft.ASP.NET Core.OpenAPI. Execute the command. Clear the console and now install the second package for Scalar, which is Scalar.ASP.NET Core. Go to the program.cs file, add the OpenAPI services. So call build.services.add OpenAPI and call map OpenAPI to map an endpoint for viewing the API document in JSON format. And now integrate the OpenAPI endpoint with Scalar. So call app.map Scalar API reference. Time to test the interactive API. So run the project. Navigate to the Scalar root. We have our interactive API with Scalar and OpenAPI. Go to the match all endpoint. Let's send a request. So click test request, click send, and we have the response with the 20 documents from the product index. Stop the API. Add a configuration in the launch settings.json to load the Scalar interactive API. So go to this JSON file and from the HTTPS, we'll define a launch URL, which will be Scalar. Let's save it, run again the API, and we have our interactive API. Close the window, go to the program.cs file. The second query we'll see is the match query, which returns all documents that match a provided text, number, date, or Boolean value. So add a new endpoint. Let me copy this match all endpoint, define a get endpoint with a different route, inject the client, and now let's perform a search request. We'll define the index. The size is not needed anymore. So from the query function, instead of using the match all, we'll create a new Lambda function. So we'll define the field to match, create a new field class, and we'll pass the field name as a string and call the query function to pass the value to match. So we'll pass a new query value property. And finally, we'll return the documents. So we'll receive from root the field and the value to match. So add two root parameters, the field and the value. Add these two parameters in the get endpoint. Let's create a new dynamic query value based on the field type. So if the field is price, we'll convert the value to decimal. So call decimal.parse based on the value. Add a second ternary operator. If the field is created date, we'll convert the value to a datetime object. So call datetime.parse. Otherwise, we'll just use the string value. The third query is the temp query, which returns documents that contain an ETSA temp in a provided field. So let's copy this endpoint, define a temp root, we'll pass the field and value root parameters, we'll inject the client, we'll remove this dynamic query value, we just simply pass the string value. So instead of calling the match function, we'll use the temp function. We'll define the field and the temp value, so call the value function, and we'll add an additional temp parameter to ignore the case, so call case insensitive and set it as true, and finally we'll return the documents. The next query is the match phrase, which returns documents that contain an ETSA phrase. So add a new get endpoint, copy the temp endpoint, modify the root as matched phrase, pass the field and value root parameters, inject the client, perform a search request, define the index, and from the query we'll call the match phrase function. We'll define the field, and instead of the value function we'll call query, and we'll pass the phrase to match and remove this case insensitive method. Return the documents from the response. The next query is the wildcard pattern, which returns documents that contain temps matching a wildcard pattern. So create a new get endpoint, copy the last one, and we'll define the wildcard root, define the field and value root parameters, inject the client, perform a search request, define the index, and from the query we'll call the wildcard function. We'll define the field, and instead of calling the query method, we'll call wildcard and the value to process, and we'll ignore the case, so call case insensitive and set it as true. Finally, return the documents. The final query is the range query, which returns documents that contain temps within a provided range. So create a new endpoint. Let's copy the wildcard endpoint and define the root as range. Instead of the field and value root parameters, we'll define a min and max values to apply the range filter based on the price. So add the parameters, modify the parameter names, perform a search request. From the query, we'll call the range filter. From the range, we'll define a new number range, create a new lambda expression, and from this lambda expression, we'll define the field, which in this case is the price, and we'll return documents less than or equal that the maximum value. So call the LTE function as the match range. We'll convert this value as double, so call double.parse, and we'll return documents greater than or equal that the minimum value. Remove the wildcard and the case insensitive, save it, and return the documents from the response. It's time to test all the basic queries, so run the API. Go to the first match all query, send a request. We have all the documents from the product indexed. Now go to the match query, define the field, the name field, the value, as wine, send request, and we have the documents that contain this text value. We can apply this match query to Boolean, numeric, or date values. So change the field as price, copy this value, and send request. We have the document that matches the price. Now select this created date value and filter by date, send request. Go to the temp query. So for the field will be name and pass a value. These two documents contain the wine, which is an exact temp. But if we try to copy these two words and send request, we have no documents because the temp query returns documents that contain an exact temp. We can use this value in the match query to the name field and get the result. Now go to the match phrase query, define the field and copy the same value. And we have the document that contains this exact phrase. We can copy this part and send the request. We have the same result. Now go to the wildcard query. Let's apply this query to the name field and define a wildcard pattern, send request. And we have the documents that match this wildcard pattern. We can apply different wildcard patterns. For this pattern, we have multiple documents, as you will see. And go to the last query, the range query. We'll define the minimum and maximum values for the price field. So select the minimum as 50 and maximum as 100, send request, and we're applying the range query. Now let's apply an exact range. Copy this minimum value from this document and a maximum value, send request, and we have the two documents based on the range filter. So in this demo, we've learned how to execute basic queries with Elasticsearch in .NET.